Anslinger.
And I'm Charlie.
And the title of our project is BioNanoTechnology in the treatment for cataracts. Now, when originally looking for a problem, I ended up taking off a statement that Dr. Horton had actually made during one of the lectures about how cataracts, as people age, your vision gets cloudy, and I actually found that it hit close to home because I've had multiple family members who have had cataracts, so I wanted to learn more about it. And originally, what a cataract is, it's one of the most common forms of eye illness, and as someone ages or as their lens itself gets damaged, the protein solution called crystalline proteins, they actually begin to pull apart, and the solution becomes cloudy as they become oxidized on the lens itself, eventually leading to blindness. And what we wanted to do after looking through the treatment for cataracts, it requires actually going in, removing of the entire lens from the eye and then replacing with an artificial lens. We wanted to find a way where we can have someone keep their actual natural lens in which we came up with.
Given the problem that cataracts are caused by crystalline protein itself and its oxidation, we also have to clarify that there's different types of crystalline. In particular, we have two types that are really important. We have the alpha crystalline, which is this one right there, and the gamma crystalline. Now, what's important about these two? Both of these are responsible for maintaining the transparent, in a way, structure of the eye. So what happens is the gamma crystalline is making sure that the alpha crystalline maintains the structure, not failing. And over here, what we have is an example of a nuclear cataract, which is the one that happens inside the lens. But there's also different types of cataracts. Most of them happen in the back part of the eye or in the white of the eye. But in the case of our project, we're focusing on the ones that affect the eye and this side. Okay.
So our overall objectives, basically what we hope to accomplish by the BioExpo, considering it's currently conceptual, is to have an overall diagram of what the procedure would look like in order to synthesize these proteins. However, what our proposed solution would be, using a nano printer, which has been able to print biological material at a very small scale. We would recreate the structures of crystalline and form an actual solution, and then somehow adhere it to something along the lines of a medicated soft gel contact lens. So after the removal of the cataract is done and your lens is there, you would place the actual lens with the new crystalline protein on it onto the eye, and it would adhere to the eye and then once again restore vision, as the crystalline itself is what makes the eye transparent and allows you to see through.
Alright, so now we're going into the methodology of all this. The methodology doesn't go far from the basic conceptual process behind making a medicated contact lens. So basically what it's composed of is just two phases, so to speak. It's a printing of the proteins and the application of it into the contact lens. So essentially what we're trying to do is, after we print the protein, which is crystalline obviously, what we want to do is, all of this is alpha, beta, and gamma. And have it in a solution that encourages protein to grow. If we could do that by BioExpo, that would be great. So yeah, that's a basic process. It's just making the solution and inserting the contact lens. And since the contact lens is made of a hydrogel, it means that it absorbs the liquid, so therefore it allows for easier application. That's the concept of all of this.
Even though it's still in a conceptual phase, just a few tentative materials that would be required, such as an aqueous medium, water-soluble, crystalline. there is a lot more that would be required. However, we still need to do research into how exactly we would adhere the crystalline to the lens, and as well as how we would adhere the crystalline to the contact lens as well and keep it alive.
Yeah. Also, another thing that I wanted to add, and of course this is all conceptual, what we not initially wanted to do, but also as an alternative, and if we can, till the BioExpo, what we want to do with particularly the solution that goes into the contact lens, we want to encourage synthesis. We're basically taking those amino acids and forming them into the protein, the crystalline protein itself. Of course, this is all conceptual. Hopefully, we can do that at the time of BioExpo.
And then relevance to biology, it's relatively self-explanatory. We're trying to work in increasing human health and hopefully, because the crystalline protein, the really like hard thing behind cataracts, the crystalline protein is only made for the one time, and then it's supposed to continually repair itself as it becomes damaged. But what we hope to do is basically give people a 1.5 to almost 2 lifespans worth of the protein, because it would basically be a fresh start over. And then the robust biology, it involves process of the human body and trying to create and do something with proteins, especially with the microflutter technology that I haven't seen done with very much anything.
Right. Also, another process that we want to tackle, we also want to tackle the genetic aspect of cataracts, or the crystalline protein, what makes the protein fail in a way. But we haven't tackled that side of the project yet. But yeah, we hope for the future. Alright, now we're going to present the potential companies of interest, starting with National Science Foundation.
The National Science Foundation, they're dedicated to the advancement of science. They do a lot of funding of a lot of different projects. Normally, I've gone on their site quite a few times, and this would be something that would be of interest to them, as well as the dedication to health.
Right, and this is also we can get funding from the National Science Foundation.
If we're looking very long term and to go
right.
from conceptual to actual reality.
Right. Alright, so up next it's the Sonopod company. Now this company in particular is really important because this company would be the one that supplies us with the nanoprinters. They have previously dealt with organic materials and liquids, so that's important. It can also print DNA, which means direct influence on those components, so we could basically manipulate the components or the genomes that affect or make the crystalline protein fail in a way. Makes sends a wrong message of folding the proteins incorrectly.
And the Research to Prevent Blindness, that's the actual name of the organization. They put a lot of funding into research in order to prevent blindness, and that's basically what we would be doing. Not necessarily in the sense of someone who has been born naturally blind, but to prevent people from going through cataracts, or having and allowing them to actually have a natural lens and not have to worry about if their artificial lens is going to shift, or if there's going to be after surgery cataracts, which is actually not super common, but it is a risk associated with having cataract surgery, as post having it all removed and having the new lens placed. A new cataract can form over where the actual artificial lens was, or a cataract, it's basically scar tissue starts to grow over the cornea itself.
And so also we have this company called Napsys. Now this company is particularly important because it involves our majors, which is nanotechnology. It involves the usage of nanodetectors. Now what this means is it uses a process in which it analyzes strands of DNA, and it's a process that's basically really fast, and that's why it's well known. It also, that's part of it. It maps whole genomes, which makes it relevant to research again if we are going to tackle the genetic aspect of crystalline and the causes of cataracts. And it could lead to further research and funding, hopefully, for the future.
and our acknowledgements, we would like to acknowledge Dr. Horton and Dr. Coughlin, as well as the Florida Poly Library, for assisting us in our concepts and for the research. There's our citations.